Before we start the retake video, I just want to review once again what equations are. And the idea of an equation is that you are continually making both sides of the equal sign equal to each other, or continuing to make a true statement. So for example, if I multiplied both sides by 3, 5 times 3 is equal to 5 times 3, which means both sides of my equal sign are still equal to each other. We still have a true statement. If I then take this problem and let's say I subtract 3 from both sides, as long as I use the commutative property and remember that I can't flip the order on subtraction, I still have 12 is equal to 12, which is still a true statement. But if I do something different to each side of the equal sign, let's say I add 4 to the left side, and on the right side I multiply by 4, I get 16 is equal to 48, which is a false statement, and therefore my solution to this problem would not work. So let's do a couple examples. For the problem on the left, the first thing I'm going to do, because there are no parentheses, is I'm going to draw a line down my equal sign right away. From here, I find the variable, which is x, and I ask myself which number is farthest away from the x, but still on the left side. In this case, it looks to be the positive 8, so I'm going to subtract 8 from both sides. Because positive 8 plus a negative 8 is 0, and I get 9x is equal to, and this is where I got to be careful, negative 18. From here, I can divide both sides by 9. 9 divided by 9 is 1x. Negative 18 divided by 9 is a negative 2. And that should be my answer. Now, like always, I have to check my answer. So I'm going to plug in negative 2 instead of x in the initial problem. And this should be a nice reminder of why we did function notation earlier in the year, because it is the same process that we're doing right now. We get negative 18 plus 8 is equal to negative 10. That is a true statement. Therefore, we have to have the correct answer. Let's do one that's a little bit tougher. We have the distributive property again. So from here, I'm going to distribute negative 3 into both of these numbers. And this is where I got to be very careful. I have to do negative 3 times positive 3x, which is negative 9x. And negative 3 times negative 1, which is positive 3. You also could think about this as negative 3 times positive 1, and then you would get minus a negative 3, which is the same thing as adding 3. So both ways would be correct in that example. Once I have the parentheses gone, I draw my line down my equal sign, and I'm going to solve it just like I solved the last problem. Step 1 is I want to subtract 3 from both sides. I've now done that like 5 times. This is 0. We have 9 equals negative 9x. Divide both sides by negative 9. One common mistake here is to divide by a positive 9 instead of a negative 1, which, remember, these are multiplying together, so we have to divide by the opposite because I need this to be 1x, which is equal to negative 1. And now I can check my answer. I go negative 3, parentheses, 3 times negative 1 minus 1 more, and I want that to be equal to 12 when I'm done. Well, 3 times negative 1 is negative 3. Negative 3 minus 1 is negative 4. And negative 3 times negative 4 is equal to 12. Therefore, we are correct. Now, something that some people lose track of when solving equations this way is, why are we solving equations this way? What type of problems would I be doing in my real life that would actually be using these strategies? And lucky for you, you have a math teacher who came up with an example for you right away. You're welcome. Mr. Schmidt and Braden are having a basketball shooting competition. Because Mr. Schmidt is clearly superior, he is going to give Braden a 5-minute head start. What a nice guy. Mr. Schmidt then makes 8 baskets a minute, while Braden makes only 5 baskets a minute. Who will make 40 baskets first? Now, some of you would solve this by using a table or by guessing and checking, but I want to remind you that that strategy is still solving an equation. Just because you don't write out the equation doesn't mean you're not using equation reasoning to solve the problem. And that's going to be a big misconception in this unit, especially with your journals. So let's look at Mr. Schmidt over here first, who's most definitely going to win, obviously, because he's the best. Then over here, we'll look at Braden. And even though we don't have to make an equation in this problem, because it doesn't say we have to, I'm going to show you how to make the equation to solve the problem, just to show you how. So for Mr. Schmidt, we're going to do baskets is equal to, and we go find how many baskets he makes a minute, 8 baskets per minute, which means it's 8 times minutes. So 1 minute would be 8 baskets, 2 minutes will be 16 baskets, 3 minutes, 24 baskets, which means to make 40 baskets would be 5 minutes. Let's see if Braden ends up beating that. He probably won't. So from here, Braden makes 5 baskets a minute, so it's going to be the same setup. But he gets a 5-minute head start. So in 5 minutes, Braden gets plus 25. So he's 25 in the lead before he starts. So to find 40, we do 40 is equal to 5 times m plus 25, which means we will get minus 25 from both sides. So I get 15 is equal to 5m. So m is equal to 3. So 3 minutes, which means that whoever made this problem messed up because somehow Braden won. So Braden made 40 baskets first. He must have cheated. Only possible explanation for what happened here. As always, if you have any questions, make sure you let me know. This should be review, but if it's totally new material to you, make sure we sit down and do some problems together.